parte, and Ruckus, and especially our platinum sponsors, Google, Abranet, and NTT. Now, I'd like to invite Marcelo Molinari from Ruckus, and he will talk about Wi-Fi and IoT for smart cities, and he brought Ruckus in person. Well, it's off. Well, I brought Ruckus. He will be watching the presenter and the material, and I hope I can share with you our solutions for IoT and smart cities. Anything you want to know will be at our booth. The idea is to talk about the smart cities idea and the points that are leading us to develop this market. Well, the video signal has gone. Okay. So, one of the things we try to do is to find all these drivers, and here we have some of them. We have this concept of digital device, expectations of people coming to our city, new technologies, economic development, a stronger organization, public security, and infrastructure renewal. So several topics that are drivers of this concept of smart and connected cities. In these two graphs, we have Brazil right in the beginning that a lot is missing. We have lots to do to improve the connection rate in our cities, both in the urban environment as in the rural environment. In the first graph, we see that the non non-connection rate is around 10%. And in the rural environment, it is much greater, 60%. So a lot needs to be done. We are working and you are working in this environment. We need to eliminate this digital divide. We have this social impact because some are connected and others are not. And in schools, this is quite evident. If a student has more access to information with internet in at school and at home, they can stand out. So one of the points that the city governments try to do is to complement to unfavored classes. If I can provide internet access in schools, squares, this can complement and help those who have not a dedicated access. The objective is to decrease this division. And we have several initiatives around the world. In Brazil, we are working with some municipalities. The city of Vitória is one of the examples. We create hotspots to provide secure and controlled access and providing this band to cities or to providers linked to the municipalities. And concerning intelligent city, we have several applications possible. We can have mobile access through a smartphone, public security with announcements about intense traffic or any other risk situation, healthcare, in transportation, we can think about uh, bus or train stops with intelligence where it's possible to know in real time how long it would take for a train to arrive in the environment, the weather monitoring like weather forecasts or the levels of CO2 and UV rays. So we have lots of equipment that being equipped with Wi-Fi will allow for this integration. In terms of energy, we can think about meters connected to the network, so you can see the expand of every company, for instance.
Aplicações e
So this market is increasing with several brands with a very rich system. Another important issue is how to fund or to pay for this. We can have a scheme where the city funds, and this comes in the form of taxes, or you can establish public-private partnerships or service providers that are eventually charging for this access. And how much this should be sustainable? There is a structure that has to be uh, insured. Everything must be insured, and also the user bases. The user base increases, and you need to add more access points and the backend to support this increase in users number.
de um investimento assim,
The return of such investment can be seen in three different aspects. You can charge directly for the access, whether it's a hotspot or an IoT network. You can have a direct entry due to this new network, or a political gains. Oh, I'm improving my city. I work in the city hall in a department responsible for the technology. I want to renew the image of the city and attract more tourists, and the social gain related to the decrease or reduce the so-called digital divide, giving access to information whatever is the environment.
como fabricante, temos tecnologia.
Being a manufacturer, we provide the Wi-Fi technology, and we are extending this technology to the IoT world. In addition to the 5 and 5 giga connection, we are launching products to integrate a pre-existing Wi-Fi network with a Bluetooth energy. So with the Wi-Fi, I can connect myself to equipment that support Zigbee or Bluetooth, whether they are sensors, lighting equipment, or digital monitoring. It's not my objective to go in detail about the products. We can do this in our booth, but we will work basically with access points that we are in the bottom part of this slide, also with integration for to Zigbee or Bluetooth low energy. In a other layer, we will have the switches of several sizes and formats to take this traffic upwards, and control layers of all this wireless and cabled environment with a software layer where you have the applications and usage policy that I will impose to my network. And as I mentioned, in a smart city solution, we contemplate specific apps that relates to the community, but you can encompass everything. Can be stadiums, shopping malls, train or bus stations, airports. So all these areas can be contemplated with services like monitoring or high speed and secure connectivity or information of public interest.
Alguns exemplos aqui, agora por vertical. Então,
Now, some examples by vertical. In the transportation world, we can think about mechanisms to optimize the routes of public transportation or the timetable. What time on this date this bus will arrive, or to manage parking lots where I am with I locate myself by the GPS. Oh, and there is a parking lot in the 3 blocks or in a parking lot. In security area, public lighting, control of crowds close to a stadium or an event, video monitoring. All of these are very demanding points in terms of environment, quality of the air, weather conditions like humidity level or UV emissions according to the season, and flood, which is very important here in São Paulo. All this flood monitoring can be incorporated to this environment. In healthcare, epidemics control, response for public emergencies, patient identification in utilities, energy, monitoring the electricity or water meters, and monitoring in terms of waste. And finally, the municipalities, they can invest in access, creating hotspots and also checking the location of assets. Suppose we have public areas that are a target and I want to make a triangulation. So all possible uses in the smart city. Well, we also have monitoring platform to big data analysis and security, and also for onboard. It's interesting not to have all the time presentials to every hot spot when I go back to the same place. We have onboarding services that we have available to make this process automated and install digital certificates in the smartphones in a very easy way. And so the user will have access to certain resources according to a profile. And when connecting to a Wi-Fi with this certification, he or she will have immediate access to these resources without the need of login and password. We do not work alone. I don't believe that there is a vendor working alone in this world. And these we have a list of brands that we have partnership, some of them well known here in Brazil. We see Philco, Philips, LG, Hitachi, Purple, Contact IOs, Track R, Abloy. These are some brands with whom We already have partnerships in the world of smart cities and IoT. Now I will go into detail in the IoT part.
O fato é que, para nós, como fabricante no mundo de Wi-Fi,
As a manufacturer
sem fio,
in the Wi-Fi
esse é o nosso
sector,
suporte
this
inicial,
is
nós
our
equiparmos
starting points.
os
We
routers
will equip it,
com
HUKUS access points
interfaces
with
Bluetooth Low Energy ou interfaces.
Bluetooth Low Energy or Zigbee interfaces.
Bom, eu vou aproveitar e já
Well,
mudar para minha outra apresentação, mais alguns slides que
I
falam
will
desse
go
assunto
to
IoT.
another presentation that also covers this IoT subject.
Muito bem. Partindo de um access point,
Well, going through an
o alcance desse access
access
point
point, I want to
de diversas
extend
formas.
the reach of this access
Proporcionais
point
aqui
in
no slide
several ways. What
faz
is
parte
important here
do inferior
is
direito. Então,
the
onde eu tenho um
lower
access point via
right
internet,
corner.
oferece
You have an
Wi-Fi,
access point through the
através
internet with an
através
Wi-Fi. It is already possible
do
to
LTE,
have
Infraestrutura,
a backhaul
backhaul,
using LTE with the 3.5 gigahertz.
IoT.
But the most
Então,
important here
Wi-Fi
is to talk
transforma,
about
avança
IoT.
na direção dessas
The
tecnologias
Wi-Fi
todas.
advances towards all these technologies.
E no mundo de IoT, o ponto
In the
ou o objeto de trabalho
IoT
são
world,
esses
the
devices todos.
object
Podem ser
of work
smartphones, podem
are
ser
all these
câmeras de
devices,
segurança, podem ser
smartphones, thermostats,
sensores
lamps,
ambientais, podem ser
environment
routers
sensors, lockers,
ou
or
tracking devices. Então, todo
tracking
esse conjunto
devices.
de objetos
All these objects
conectados
are
são esses
connected
que eu quero ir conectar.
or connectable is
Na parte de cima
my
aparecem as
target.
plataformas
Up there, you
que
have
nos
the
provisionam
apps,
os serviços,
platforms
perfil, as
through
profiles,
where I create the
aplicativos,
profiles and provide the
os
service
equipamentos
or
conectados,
bring the connected equipment to the network, whether sensors, tracking
e
devices, or
que
any physical
nós,
object.
como
And
fabricante
as
de
a
máquinas
vendor
eletrônicas,
in the
trabalha nessa área de
network
network.
sector,
Então,
we work in
diversos na
this
nossa mesa,
sector. We have
equipamentos
several
conectados
apps
Bluetooth ou
equipped
Zigbee,
with Zigbee or
agora
Bluetooth
vão
interface, and in the
interfacear
future,
diretamente
LoRa
com
will
objetos
interface
conectados na parte de
directly
baixo.
with the objects.
Como que isso se distingue do ambiente atual? Já se montam redes com
How different it is from the current environment. We have networks with IoT, but today you have to create a Zigbee or
Então,
Bluetooth
os
dedicated
connectors,
network.
portanto, Zigbee,
You may have hubs supporting
essa
Zigbee or
sigla Z,
Bluetooth.
é o logo
The
da
Z
tecnologia Zigbee,
is the
eles
Zigbee
servem
technology
para essa
logo. They are
distribuição de
connected
todas as
to the
interfaces.
devices, whether they are lockers, lamps, or thermostats. They are connected via radio. Zigbee is a ULF modulation with an internet port for the physical infrastructure connection. It's a parallel
Então, eu acabo
network.
tendo uma rede
So you keep
Ethernet
Ethernet
portas
network
Ethernet
with
para suportar
Ethernet
gateways
ports
e
to
outra
support
Ethernet
the APs
portas para
and
suportar
another Ethernet
gateways das
network with other
Zigbee ou
ports to
Bluetooth.
support the
Uma rede
gateways for
separada.
Zigbee or
Nosso
Bluetooth.
objetivo
So we
é
created a
convergir
separate
as
network.
duas redes
Our
totalmente,
objective is
de
to
modo que eu
converge
mantenha a minha
both
própria rede
networks
Wi-Fi
into one. I
e
keep
que
my
esses agregues
Wi-Fi
com
network
interfaces
and I equip
Bluetooth
these apps
Zigbee, que é o que
with
aparece aqui. Então,
Zigbee or
a minha
Bluetooth
rede
interfaces.
Ethernet
Here is
Wi-Fi já
my
existente,
Ethernet
agora
Wi-Fi
também consegue
existing
estender o
network
alcance
that extends the
ambiente
reach
para
of
IoT.
my network
Um dos
to
principais
IoT.
desafios para essa
One of the
conversão
major
é
uh,
não precisa ter
cases for this is hotels. They use hubs, and the highest level hotels, they use it to ensure that the guest checks in, receives a profile, and through the smartphone, the guest can open and close the bedroom, can control the temperature, the lighting, and with this profile. From 6 months from now, he goes to the same hotel. He has already his profile. The profile knows the temperature, the type of illumination it likes. So the major users of this technology is the hotel, integrating a pre-existing Wi-Fi network and through it to reach all the IoT objects. Our proposal is to converge these networks, to use an existing network to go further with an IoT network. In the current world, we create a separate network with dedicated gateways, cabling, and a separate managing platform. So our roadmap is to have a structure with an environment to control, develop applications, and integrate services within one single architecture. This is what we call Riot, virtual IoT groups. Our purpose, our objective when launching these apps supporting Zigbee and Bluetooth to develop open platform with APIs so that partners and universities develop applications to ensure secure and control access or specific profiles for each of the types of devices that will be reached through Zigbee or Bluetooth. This is our architecture that we are just launching, and the name is vRiot. The idea is that through this architecture, our controller that today controls switches and access points will also be capable of receiving control functions for IoT, whether illumination, lockers, or thermostat, which are the examples shown in this image. For this, we will have portals with a specific setup for each type of equipment connected. Maybe one portal for lighting, one for physical security, one for environmental control. This portal via API talks to our controller that in turn sends the control to all equipment. This is our architecture that we have already developed.
Dos primeiros componentes agora.
We are launching now in December these components, and during next year we will continue to add more components. So this is what I want to share with you, the idea of having one single network for Wi-Fi and IoT, and this network will transport the command messages to the equipment, and it's a diagnostic network. I need to have the hardware for this, but I can have Zigbee, BLA, LoRa, and other mechanisms with the specific apps. And with this, we expect to offer this architecture for smart cities and also other markets and other verticals. Well, I think I still have 5 minutes. I think we can open for questions in case you have any.
Boa tarde a todos. Em vista do que a Hux tem se preocupado aí com a
In face of integrating all devices in one single network, I have a question. To guarantee IoT security, as that is the responsible device for the integration. What about security? How are you concerned about that? As the main problem in the networks are the IoTs. Several attacks happen. So what are you doing in terms of security? Well, we are just investigating it. We will impose a security between controller and infrastructure. Philips, for instance, Philips Rahel, they have a hub. Zigbee talks to bulbs. That is an internet connection. Our main goal is to keep a safe connection between this hub and controllers. But we will depend on agreements to advocate for safe, secure protocols between hubs and devices. Hookers will not have direct access to that final technical group. Middleware upwards. The idea is to keep a secure rule structure where we will deploy protections, resources, ACLs, encryption, spoofing protection, attack protection from but it's the controller layer which will talk to a native hub from Philips or anywhere else. We'll just control the network layers. But we know that it's very important to ensure security end-to-end. The idea is to find partners or way to guarantee security end-to-end. We haven't got a fine solution for that yet.
Alô? Boa tarde, Ibirissol do...
Hello, I'm from the National Research Hub. What's your opinion? Is there any trend to integrate software radio, to integrate new protocols for Internet of Things which are not Bluetooth, Zigbee? Software-defined radio on a radio level, not just the data play
Rede Ethernet
or Ethernet. I cannot say that we have software-defined radios, but what we do have are APIs. And you can create an application to access the controller API where you schedule the RAF. You may program that via REST.
Bastante tempo, então
And that's available for a while. That's a possible methodology where you can define safety policies, access hub points, and IoT. I'm from University of São Paulo. 2.4 spectrum pollution. Both Zigbee and Bluetooth, they pollute, and Zigbee has got many applications which allocate the 2.4 spectrum. How to manage that pollution? To manage the Zigbee channels? How? Good question. Thank you. We will be able to have access to hubs
from Philips and any other brands, and I'll have access to APIs, and I can guide a channel change. They will know which channels are in use for the conventional Wi-Fi.
O gateway ou para o hub.
And they can request to gateway and hub to change a channel. In 2.4, that's a very complicated situation. High level of pollution. So we have to live with that for some time. But we have some resources. By that central portal, we'll be able to dynamically select channels for 2.4 APs.
Ok. Ok? Obrigado. Obrigado a todos.
Thank you. I'd like to thank our sponsors. I will not repeat the name of the sponsors. Chris saying so. I have two reminders. Talk with Nick outside. You find the whole crew there for your doubts or complaints, anything. We forgot saying in the morning that next room, there are two small rooms for meetings. In case you want to use any one of the rooms for private meetings, just schedule your slot. And going on, I'd like to invite Paolo Lucente from NTT, who will address PMA CCT.
They caught me back in '85 when they dropped the net down from the sky. In the jungle I was so alive, now I just survive. 12 monkeys in the cell with me and 8 of them are family. I fathered them in captivity, prisoners from the start. Smeared glass cage.
Hello, hello. So this is Paolo Lucente from NTT Communications.
Eu sou Paulo Lucente, da NTT.
The author of this tool, PMSCCT, and I would like today to speak to you, share a little bit with you our experience at NTT with building a pipeline for network analytics. So this presentation will be in English. There will be a few degrees of brutality here because I have as many slides as minutes available. There will be super technical slides, so unfortunately I don't have many graph and nice stuff over there. So if you are into measuring traffic, if you are into NetFlow, BGP, hipster things like big data, then you will have a lot of fun. Otherwise, just relax a little bit and wait for the next presentation. So that said, I am Paolo Lucente. This is from my driving license a few years back. If you see now, I have a little bit more white hairs. I've been doing analytics and, collecting data out of networks for many years in different, environments, eyeballs networks, transit providers. Also from, a vendor perspective, I was working for Cisco before, NTT. And yeah, that's enough about me. I would like to divide this presentation in two parts. First, a round of introductions about, entity and PMSCCT, and then we go in the core of the presentation. Of course, we start from an introduction of entity because I believe nobody in this room really thought, that you could get away from a presentation without marketing slides, right? So entity is the greatest network, ever. You should, all have a transit from entity. And, we are one of the largest company on the globe, like 250,000 people. And entity communications, which is handling a lot of, transit, globally. It's a smaller business unit with just around, 18,000 people working. We are, one of the top, transit service providers in the world, and we are present, as you can see there, in many countries, everywhere. We are present also in Brazil. And this is a little bit of a map of our network. You see a lot of presence in Asia, North America, and Europe, also presence here in Brazil. And, with those green and red thing, you can see new data centers and new POP that we are building. So we are expanding our network. So speaking of PMSCCT would be this collector software with the, I'm pointing there. In the orange box, so it's really that octopus with that angry face. The angry face is simply because nobody knows how to spell PMSCCT, and it differs from culture. So that octopus is very angry, and so you see it's in the middle of everything. You have a number of data capturing methods like lib pickup, netflow, sflow, or streaming telemetry. And then, so with PMSCCT, you can get this data, and then you can correlate it with other data like BGP, BMP, IGP information like ISIS, GOIP information, or any other kind of information that you like that you can supply through maps. And then essentially you can store this in, a number of backends like well-known relational databases, NoSQL databases like MongoDB or BerkeleyDB, flat files, memory tables, and also message brokers like RabbitMQ and Kafka. And we will see better what RabbitMQ and Kafka means over here. So why, they are very important. We have some easy use cases for PMSCCT. So if you are, for example, collecting NetFlow or IPFix, you can point this to PMSCCT. You can write it to flat files, and you have your nice, traffic written in flat files. You can take sflow. You can take it through PMSCCT, and you can replicate it to third parties or to other collectors and things like that. Yet again, another simple use case, you can get BMP. BMP stands for BGP Monitoring Protocol, a very interesting protocol that is being developed. So BMP is already an RFC, but there is a lot of interesting developments going on at ITF in the GROW working group. You can collect BMP data, pass it through PMSCCT, and write it to a Kafka message broker. Or yet again, you can, have you can sniff traffic through lib pickup, and then pass it through PMSCCT and export it as IPFix. So a PMSCCT can work as a collector, as a replicator, or as a probe. A little bit more complex use case, right? So you can, collect NetFlow IPFix. You can pass it through NFACCTD, which is one of the daemons. You can correlate with the BGP. You can, at the very same time, T, so replicate to third parties applications, like, Arbor, or, you name it, whichever other, application is collecting flows and needs to be replicated flows. Then the combined NetFlow IPFix, you can aggregate it in different ways, right? And for example, you can send a totally unaggregated view of the NetFlow plus BGP. NetFlow plus BGP would be, for example, traffic for AES path, right? Traffic for AES path, or how much traffic I'm sending through a transit provider to Google. So does it make sense for me to have a direct peering with Google? The answer is yes, but maybe for other cases you want to evaluate better. So that is NetFlow plus correlated with BGP. So totally unaggregated, you can send it to flat files, or you can aggregate it in some specific format and send it to a MySQL database. Or, for example, you can send raw BGP data to Kafka, right? So as JSON, so you decode the binary BGP into JSON, and and you send it through a message broker like Kafka, so that then you can ingest all your BGP into a database and then do play or replay of BGP events. I was saying a couple of slides ago, I mentioned message brokers, so Kafka and RabbitMQ, and I was saying in a few slides we will see the importance of those. So the importance of a distribution layer like Kafka and RabbitMQ is that they are really the enabler for time series database or NoSQL database or column database, like very popular names that you for sure you have heard if you are interested into that space, like Elasticsearch, InfluxDB, Cassandra, Druid, and things like that, which in turn allow you to have a very nice connection with the UI, like Grafana, Kibana, or Superset, that allow you very easily, once you ingest your flow and BGP data, for example, in these databases, then you can very easily, with these UIs, explore the traffic so the data that you stored in these databases. And that is a little bit of a game changer compared to the traditional relational databases where, you store things into a MySQL database, and then what do you do with that, right? I will go very quickly through this slide, saying that PMSCCT itself is a very, flexible tool set, and it has its place in many corner of the internet service provider, of the internet in general, so service provider, internet exchange, and things like that. And it comes with a lot of flexibility, and one of my tasks is that with flexibility comes complexity, and I'm trying to, give the flexibility while, containing the complexity of the tool. So some non-technical facts about PMSCCT is that it's a very old project. I started, it says more than 10 years ago. It's really almost 15 years that I started the project. It comes with a very ugly name. You cannot spell it as after the second drink. Like, I'm a very terrible marketer, so I know I can never be marketing myself. It's free, open source, and independent. You can really go on GitHub or on the webpage of PMSCCT, download it, and things like that, connect with the community. It's under active development. In fact, if you go on GitHub, you will see that the latest commit was yesterday from my hotel room in São Paulo. Innovation is being introduced, and also, I come myself from the service provider community, so I try to connect this tool a lot with the, the needs of this community. So I try to meet, if not anticipate, the needs of this community. Some technical facts. It comes with a very pluggable architecture. For example, recently it was very easy to add streaming telemetry, to the set of supported protocol in terms of, data collection, and at the very same time, supporting the like of Kafka or RabbitMQ. It was equally, very easy. You just take the API, you get just a basic structure from a plugin from PMSCCT. You take the API. Of the product, like Kafka, for example, and then you just connect the two. The only thing is that PMSCCT is written in C, which is not hipster, and what is not hipster these days is not cool. And so, unfortunately, that is the little bit of barrier over there. And with PMSCT, you can do two things. You can correlate data sources. So like I was saying, like NetFlow with BGP, streaming telemetry with NetFlow, and things like that. Or, and at the very same time, you can also, report on each of the data sources differently. And you can, snapshot the data like every 5 minutes, for example, or you can stream, all of this data as it comes, you can stream it. And, each of these things, each of these options for each of the data sources covers a different use case. So there is not really a recommendation to go in one direction or in the other, but PMSCT as a collection toolkit allows you to do everything. You can keep everything separate, you can correlate things, you can stream, or you can snapshot things, and you can do any of these combinations at the very same time. And this is precisely what I was saying. Like, you can build, at the very same time, you collect traffic or BGP once, and then you can build, different views of the very same, collecting once, different views, totally unaggregated, for example, for forensics or for security. Or aggregated to build a traffic matrix that then will be the input for your, business intelligence or for your capacity planning application and things like that. And then, it supports, pervasive data reduction technique like aggregation or resampling, very important. Now we switch a little bit more to the core of the presentation, right? So with the, what we, a little bit, having the toolkit, now let's see a little bit what is the pipeline beyond it. And with this, I will share, a few of the experiences that I went through during this, my first year at NTT. So first of all, what was also for us the motivation to build a pipeline for network analytics, because network analytics is like a buzzword, right? So there are some use cases, and the use cases that are covered, you can see they're mentioned over here. They are very, wide scoped, like business intelligence for a transit provider like NTT. It's, it means like you are a broker, you sit in the middle, then you want to see how much margin you make from customers, from peerings and things like that. Then you want to have insight in traffic patterns. So, for example, see when traffic drops or when traffic increases and things like that. This is typically an enabler for, other cases like capacity planning or, traffic engineering. And then, of course, you want also to do some forensics or post-mortem for some network events, right? So something happens, and then you want to verify what happened to traffic and what happened to BGP. You would like maybe to replay everything and make sure that that specific event will not happen again, or at least you want to have an insight in what happened over there. So what would be a typical pipeline for network analytics? So you have input data, right? So we mentioned some of it before, BGP, NetFlow. Of course, you have also SNMP, like infrastructure data, like your interfaces to which peer they are connected, with which BGP peers you have in your network and things like that. Then you have a collection layer, right? So we said PMSCT, for example, for BGP and for NetFlow. Maybe you have also, you want to build your homegrown SNMP poller basing on, available software like NetSNMP and things like that. In NTT, we have our own homegrown SNMP poller, right? Written many, many years ago. And then you want to transcode all of these binary things like, BGP or like NetFlow into something that you can, in a format like JSON or like Avro or any similar format like that. Because what you want to achieve when we are building a platform is that, the collection layer comes maybe super performing in C. But then that is the earliest opportunity where you want to transcode something in information data in a portable format, so that then the rest of the pipeline can be written in other languages, right? So, for example, the moment in which you enrich your data, like, for example, you take a BGP in NetFlow and you want to enrich it with the SNMP, or you want to enrich it with whatever other kind of information, you can do that in your favorite language, Python, Go, or whatever else that is not C. So data encoding in a portable format, it's key, it's essential. Then, of course, once you have transcoded things in a portable format, you want to put it through a distribution layer. I mention only Kafka here because it's a little bit establishing as a de facto standard for distributing information around applications. And as I was saying, then maybe you want an enrichment layer to add whatever it's not included in BGP and NetFlow and or SNMP, you want to enrich and put it in your record. So you want to build a very big tuple with all of this information correlated together so that you can explore it afterwards. And then you have ingestion. So you have the typical relational database versus a time series database. I have a slide later about this. And then, of course, you have visualization. So once things are in a database, then you want to, visualize it to explore that, explore this kind of data. Getting now we go step by step through this pipeline, so how to get the different elements. So we start from the collection, and then we will end up with the UI. I will skip through some of these slides, and I will leave them as, task or homework for later if you are interested. So starting from the BGP, which is one of the elements that you want to collect, I would say that you need BGP necessarily, especially when you are building a traffic engineering, a business intelligence solution, either for technical reasons or for topology-related reasons. So technical reasons is because the information you need for your task is not already in NetFlow. Like, for example, if your devices export NetFlow v5, NetFlow v5 doesn't have support for BGP XStop. So if you want the BGP XStop and understand what is the egress point of the traffic that you are sampling in your network, then you need BGP. Or for topology-related reasons, like, for example, you are like entity transiting traffic to third parties, or you are heavy on outbound. So like you are a content delivery network, or you are on over the top and things like that. So you really have all the BGP you have all the AS path and all the BGP kind of attributes that you want to sum up and correlate with your NetFlow. How would you collect BGP? Essentially, if you are using PMSCCT, you would be, letting PMSCCT BGP peer with all your provider edge routers, so the ones at the perimeter, so not the P routers. And you would, so all the ones that are facing peers, transit or customers. Why is that? Because then you have a visibility of the BGP in every corner of your network, and then you can optimize the exercise on the computing, right? So you have no best path computation to be done, once you collect data. And, you should also configure these sessions as iBGP, so internal BGP, and you should make PMSCCT or your BGP collector, a route reflector client, so that you get, all the routes. Getting telemetry to the collector, so you should export, telemetry can get as complicated as you want. So you should really export ingress-only measurements from the same provider edge devices. So yet again, we go to the idea that you should build and establish a perimeter of your network. And in that perimeter, you want the BGP and you want the telemetry. Also, as I was saying, from these provider edge devices, you want to sample ingress from all the edge devices that are facing, yet again, data center, peers, transit, customers, cloud, whatever is not the backbone. Why is that? Because, traffic is routed to destination with BGP, and so you have plenty of information of where it is going to. But you cannot do reverse BGP lookup because BGP is, traffic can flow asymmetrically by nature. So you should never do reverse BGP lookup. So the input interface that you have in the NetFlow record, it's key to establish who is injecting traffic into your backbone, because you know that interface to which AES is connected, or if it's not an AES, it's an internet exchange. Maybe you have also source MAC address information in there, so you can precisely determine who is injecting traffic into you. And then the rest, you can figure it out with routing with BGP. Still, let's say what could be that said. So we said the export model should be like ingress at all the edges. Let's remember that you need the NetFlow for many use cases like security, for business intelligence. So very likely you will never have a single NetFlow collector in your network. You will have several, and maybe dispersed across teams if you are in a large organization. And guess what? Routers can only export NetFlow once or to 2 destinations. So you have a little bit of a problem. So typically what happens is that you break it up in 2 tiers kind of export. So the routers are exporting to a couple, 1 or 2 IP addresses, which are effectively working only as replicator. And then these replicators, they are replicating the traffic based on some rules to the actual collectors. So to the PMSCT, Arbor, and FDump of this world, for example. So how, now that we mentioned BGP and telemetry, so how this correlation would work? Actually, it's, I would say, rather simple. And I have prepared here for you, a workflow in 4 steps. Enjoy it because it's going to be until the end the only graph, the only picture that you have. Then we go back to text over white slides. So there is this workflow in 4 steps. Like, in the first step you have, let's say that you are this autonomous system over here. So in the first step you have traffic, that is passing through. So actually in the first step we have PMSCT receiving the BGP tables from all the routers. Then we have traffic in a second step passing through, the observed domain, so through this one. The traffic passing through the interfaces is generating a NetFlow that is being exported to PMSCT. And then in a 4th step, what PMSCT does is that looking whether for that router that is sending NetFlow, whether there is a corresponding BGP table. If that is the case, then the correlation can happen, otherwise not. Of course, it's not that simple, that is the simplest scenario, and you can complicate it as much as you like by building, correlation with, mapping of routers or route reflectors to, edge routers and things like that. As I was saying, data encoding is very important, and after collection is the first thing that should happen. And you have essentially JSON. So you have essentially 2 schools of thoughts, like you have schemaless versus with schema. And of course, in the case of JSON, it's also interesting the fact that it's very easy to troubleshoot because it's text format, so you can kind of read it. And in the end, so we have to consider that many of these hipster big data technology, they ingest data in a JSON format. So you can, even optimize your pipeline using some binary format, some super cool stuff. And then in the end, you have to transcode things back to JSON because the database, the Elasticsearch or the Druid and things like that, that's what they expect. And you remember that transcoding from one format to the other, it's one of the most costly operations that you have there. So you want to transcode the least amount of time possible. So I can have a slightly recommendation to JSON rather than something more complex, unless, of course, you are ingesting in something that supports some other format, and then it makes sense too. Distribution, as I was saying, Kafka is a little bit the de facto standard over there, and it's very interesting because many applications they have native support for Kafka, so they will just produce data to Kafka and consume data from Kafka. Like many time series database, they have a module that you can directly consume from there. It's very interesting because you can model whatever producer-consumer architecture through Kafka, and also imagine you are building, let's say, a in-house product, or you are building a product, you are building this pipeline which very beautifully goes from collection of different data sources to a UI. You will always have in your organization somebody that will want to tap into the raw data. So you say, yeah, I have this very beautiful UI and things like that. I work with the Job Schneiders, if you know Job Schneiders. You try to say to Job Schneiders like, yeah, I have this nice UI and things like that. He says, no, I want the raw data. I want to look into my BGP and see what's going on. So because of that, a distribution layer is very essential so that you can really break your pipeline and make it modular in different pieces. So storing data persistently, I would say that modern networks, if you try to export data from a network, you will see, you will have tons and tons of data. You can easily get to gigabytes, if not even a terabyte, even in a single day. So aggregation, spatial and temporal aggregation is very important. And my recommendation is always optimize the computing rather than the disk space. So don't be shy and build, for example, like Cacti does, 5 minutes counter, 15 minutes counter, and daily counters, so that you will never have to, sub-aggregate stuff later on, and, build different data set for all the use cases that you need, and build that upfront. As I was saying, there are two schools of thoughts, NoSQL versus relational. I have for flow and BGP, you can really reduce whatever you want to do to a time series on which you want to go, you just want to explore it, or you want to do group buys and things like that. My really, opinion in this sense is to go for NoSQL, or what they call big data, because they are really they fit very well with the time series concept to flows, to BGP and things like that, because nowadays they all implement a subset, a meaningful subset of the SQL language, so you don't have to learn the specific languages of these databases, which was, an obstacle some time ago. They are very innovative. They are super scalable in this specific space compared to a relational database, and they come with UIs, right? So that is the very important thing. What I was saying before, you insert something in MySQL, and then what? You insert it in Elasticsearch, and you have Grafana, you have Kibana, you can explore this data. In the end, remember always, time series databases, it's not rocket science. It's just, taking a relational database, stripping it of all the functionalities, keeping only the time series part, and making it super efficient, right? And that's why I recommend to go in that direction. This would be an example of enriching data, right? So as I show you here, essentially you have a lot of BGP-related fields. You have counters, you have a time reference, because it's a time series, you remember that. And then you can add tags. And for example, you remember what I was saying before. You never do reverse BGP lookup. You always do a correlation, like ingress router, input interface, so who is connected to that ingress interface. And so this would be a typical enrichment, like you populate the peer source IS, so the neighboring source IS, so who is injecting traffic into you through some scripts that are determining, who is connected to which interface. And the very same thing, imagine that you want to have things like, my customer, so who is connected to this interface? Is it a customer? Is it a peer? Is it a transit, right? So it's things that you have maybe in some other database, maybe you have interface descriptions, and it's something that you can parse, and it's data that then you can enrich. So you see a flow record that is being sampled and it's going from this router in this interface to this other router in this interface, and then you see its customer to peer, its customer to transit, and things like that. So this is two typical, very typical examples of enrichment that you want to do on your NetFlow plus BGP data. And, post-processing and reporting, I'm not going to read you this. You will see that there are SQL queries. And why SQL? Again, because even if you are using an time series databases, nowadays you are going to explore this data using SQL. And this is the kind of queries that once you ingest data into a database, that is the kind of queries that you can do. So for example, you can see the traffic delivered to a BGP peer in each location that you have a peering, or you can see aggregate the AS path to the second hop, so you can figure out which AS number makes sense to peer next. You are not peering yet, but you will see that you have a lot of traffic to this specific second hop AS number. So you want to pick you want to peer with them, or you want to focus on peak hour data. And things like that. You want to get a different kind of breakdown of the traffic, or you want to build a traffic matrix that then will be your input for any capacity planning or traffic engineering kind of application. UI example, and this is my very last slide. There is a red flashing thing telling me that I'm going over time, so I have very high heartbeat at this moment. But let me just give you an example of what you can get by ingesting data into a time series database and connecting a UI on it. This is a very innocent IPv4 versus IPv6 traffic. So you see a lot of fluctuation of IPv4 traffic versus IPv6. It's there at the bottom. But what I wanted to show you is that with these innovative UIs that you have connected to time series databases, it's as simple as you have all your dimensions here at the in the corner, and it's as easy as you can drag and drop them and say, for example, I want focus for filter. I want to focus on the last day, and I want a breakdown every 5 minutes and traffic type like V4 versus V6. So it's that they made it. If you still remember 10, 15 years ago, you were locked with a relational database and no UI. Nowadays, you have time series databases with very intuitive UIs that are very easy to connect. And to me, that is really, what is unlocking the building of pipelines what is unlocking the build of in-house pipelines to build, to explore traffic flows. And even if I was speaking to the speed of light, at the speed of light with my Italian English, I hope you really enjoyed this half an hour and something. Check out PMSCCT if you are interested. It's on GitHub. Please give love, that's makes the ego of the developer going to the roof, and we need that. And so if you want to ask any question now, please do. Otherwise, later I will be here both today and tomorrow. Thanks very much. Oh.
Paolo,
Yes.
Andrei Rybachevsky, ISOC. Great toolkit, thank you. One question. So you guys at Entity certainly using this tool, so you have use cases. Do you have use cases encoded in sort of sample setups in GitHub maybe, so to kickstart? Because otherwise it's quite heavy lifting to learn all those tools and do the piping correctly. So
Yeah, absolutely. It's a very good question. So we don't have anything public yet, but our idea is that next year we will start even speaking more and more publicly about all of this, and we'll try to release what is possible, let's say, so that we are trying to. Our idea is to be very open with what we are going to build. So this is really, let's say, a very seminal kind of talk, and I hope that I'm sure that next year we will speak more and more with concrete use cases, and if we can release some software to the community, we will be very happy to do that.
Because it's easier to adopt an existing use case to your particular situation than build from scratch.
I totally agree. Thanks. And then I flee. Bye.
Thank you, Paulo. Very good presentation. Continuando aqui rapidamente, estamos um pouquinho atrasados.
We're running a little bit late, but next we have Mikhail from Extreme Networks.
Hello, everybody. Oops. So yeah, hello. My name is Michael Holmberg, as I was introduced. I do come from Extreme Networks. And, the topic I'm going to talk about is kind of a pretty interesting, as you can see on the slide, so how to build scalable and resilient fabric networks. So I don't know if you guys kind of are familiar with how a fabric is defined in details. But my intent of this half an hour is kind of to go through, fabrics. And, there's truly a wide definition of what a fabric is out there. So I'm going to try to walk you through, from an extremes point of view. So let me kind of just see, how many of you guys heard about Extreme? How many of you have heard about Avaya networking? And how many have heard about Brocade networking? Okay, so guess what? That's all Extreme nowadays. So what I'm basically saying is that when we start to talk about fabrics, Extreme actually acquired the Brocade and the Avaya networking business, which kind of leaves us with a wide variety of fabrics. So to start with that one, let me actually start to walk you through, a fabric definition, because, there's kind of, from an industry point of view, as well as from a vendor point of view, there's a lot of fabrics out there. Now, I'm starting this slide with MLAG. I mean, many people tend to argue that is MLAG a fabric. I tend to say yes, it's a fabric because you can do active-active fabric routing functions. Which means that in a small network environment, it might be okay. It's still a layer 2 fabric, so you have your fundamental layer 2 kind of challenges with that one. Then you go to the next one, Trill. How many of you guys heard about Trill? Some. Okay. So Trill is like using IS underneath it for topology discovery, so on and so forth. So for Trill, you have then some vendor-specific deployments or implementations, like Cisco, the fabric path. Then you go into the VCS fabric, which used to be the Brocade VCS fabric, a Trill-based fabric as well, which is like an Extreme fabric now, right? It's a layer 2-ish fabric. And then you have the Q fabric from Juniper, obviously, and then you go into the SPB fabric. So now we actually get into the Avaya stuff, which is, how many of you heard about SPB? Okay, 1, 2. So SPB stands for shortest path bridging. It's also a layer 2-ish technology. Why do I say layer 2-ish? Well, it's due to the fact that, from a kind of fabric point of view, it's layer 2 with MAC-in-MAC encapsulation, things like that. But you can actually have pretty unique kind of layer 3 VRF functions, multicast functions, so on and so forth on the fabric. So that's called a Fabric Connect, which is like you know, a kind of enhanced layer 2-ish fabric from Avaya, nowadays Extreme. So we call it Fabric Connect Fabric. Then MPLS. So then we talk about VPLS, right? How many kind of agree with me on that VPLS is a fabric-like architecture as well? Okay, nobody. Interesting. Then we go into the IP fabric, which is EVPN based. So, you know, I'm just showing you some of these fabrics here. So now when I actually say that, you know, I have like 26 minutes to talk through fabrics. So obviously I'm not going to talk through all of the fabrics. I'm just going to kind of pinpoint some things that I think is relevant to the audience here. So I'm basically going to talk about, you know, the layer 3 fabrics. And I'm going to try to you know, walk you guys through the fabric as the industry actually defines the fabric as a automated fabric where you can then, you know, create the fabric by itself. You have some signaling happening on that one. And then you would automate the tenants connecting into the fabric. So basically, you know, a completely automated fabric. Now, I would kind of argue on that one, saying that, you know, if you already have a network infrastructure in place, you would not really need to have the automation happening for the fabric itself to create, or for the fabric to create itself. So I'm kind of going to walk you guys through, you know, some scenarios, some topologies, as well as some designs from this point of view, that would you automate everything, or would you just assume and basically want to have the automation happening on the access into the fabric? So with that said, this is just a high-level kind of you know, slide showing you the technology stack for data center. Now, you are going to see the data center mentioned on many of these slides. I would kind of say the same applies in many instances for IXPs as well. As you know, we tend to see more and more of the IXP designs kind of correlate to data center designs. So I'm not going to read through this slide, you know, in details. I think it's just kind of important to understand that you start from the bottom, being, you know, the infrastructure, where you have your platforms. Could be commercial, you know, off-the-shelf silicon, or it could be kind of you know, specific purpose-built silicon. I'm not going to give you a product walkthrough on what Extreme does. I'm just going to mention that, you know, there's a wide variety of different products doing different things. Why am I mentioning this again? This comes back to my message around the fabric. If the fabric is kind of auto-configuring itself, or if it's like a closed spine leaf architecture that you just automate on the tenant side. Then you go into the different protocols you have. And as said, you know, I'm mainly going to focus on the IP part, and later on you're actually going to see why IP is kind of you know, cool and key. And then the virtualization overlay. So here you kind of start to break into a couple of directions. You could do VXLAN being a layer 2 overlay, right? And once again, you know, I'm kind of talking more of the ISP, IXP word than the data center. Obviously, this is derivated from the data center word where you had the VXLAN. Also VPLS, and I'm going to actually kind of compare these in a couple of slides, because I think it's key to understand the fundamental differences between these two. They are both layer 2-ish overlays, right? They provide a layer 2 path. Now, in a nutshell, obviously I have a couple of slides talking more about this in details, but in a nutshell, the difference is that if you truly want to put the traffic in the network where you want to have it, you need to go with MPLS, MPLS VPLS, because that would allow you to signal RSVPTE paths, which would allow me to exactly put the traffic in the network. that's where, you know, MPLS is unique because of the traffic engineering functionality. Now, if you look at VXLAN as an overlay, you don't really have a TE function within in VXLAN, right? By default, you are going to use your IP underlay doing equal cost multipathing. You could actually, you know, start to look into segment routing capabilities, things like that for doing some kind of traffic engineering. I would still argue that is that truly the case if you compare them, you know, on a high level. And then you go into the visibility. So I'm going to spend, you know, some time on talking about the visibility due to the fact that I think it's key to understand that you have challenges within an IXP. You might have a lot of R packets. Now, you know, EVPN as a control plane might address those issues, but I'm kind of thinking more from an architectural point of view of the network devices itself, where if I'm possible to actually have some kind of an application running directly on the hardware, then I can do some clever things with that one. So as I said, I'm going to walk you through that later on. Then you go into the automation part, and this is, as I said, you know, depending on how you define automation, with automation being, you know, on the access into your fabric, or would it be the fabric creating itself? I'm making some assumptions here in my presentation. I said I have like half an hour to try to walk you guys through this stuff. So I'm kind of, you know, doing this on a high level in that sense. And then you go into the orchestration management, which could be, you know, specific, vendor-specific things or open source based, so on and so forth. So this to try to build a picture for you, you know, on a high level. Now, this kind of shows you an high-level architecture. On the left-hand side, you basically have mentioning Exos. So why do I kind of, you know, put in here some OSs or some hardware? Because I think it's you know, fundamental that we understand that there's a lot of IXPs who have deployed the legacy extreme stuff, which means that once you actually start to go with an overlay, which could be VPLS or VXLAN, now you could have, as you can see saying there, that it's like a you know, fabric quotation mark, because today in Exos we actually do support a fabric-like spine leaf close architecture based on OSPF, where you do some clever things with you know, OSPF opaque LSAs type 11, where you could signal your VXLAN VNIs through your OSPF network. But keep in mind that this, as I was saying, that the fabric automation could be either built in the fabric or, you know, on the access side. So this clearly happens on the access side, where you would then use VXLAN as an overlay, where you would be able to signal those VNIs, your virtual networks, through your OSPF backbone with a given LSA type. And then, you know, as you can see, then you have EVPN being a control plane as well for VXLAN in the Exos environment. So basically both are supported on the Exos platforms. That's coming from the legacy extreme. Then on the right-hand side, if you actually look at, or actually, what I didn't mention on the slide, you can see the controller-less or the controller-based overlays. So I guess we all understand that a controller-less is basically your VTAPs residing on your leaf nodes, while a controller-based is something like NSX, for instance, where you would have your VTAPs residing on your vSwitch, and basically the fabric being just an IP underlay for transport there. So on the right-hand side, you basically then have, you know, one being obviously the BGP-based EVPN as a control plane for your layer 2 overlay. And then you have a controller-less as well, as I was mentioning. And this is then kind of more going to the IP fabric, which I'm referring more to the, you know, the legacy brocade stuff like the VCS fabric and the IP fabric on that side. So as you can see, there's kind of multiple kind of options here for fabric architectures. And I said, I want to mention this due to the fact that looking at the deployments out there, and I'm working pretty heavily within the European IXPs. So looking at the market share point of view, for the left-hand side, the extreme-based IXPs or running extreme, you have like 26% market share, and the Brocade, you have 29% market share. So you can see there's a pretty good mix on those ones. So there's a clear reason for why you would choose to go with one or the other one here. Moving ahead, so I think there's not really anything kind of that big importance on this slide. It's more or less a follow-on on the previous one. This is just defining the hardware itself. As said, I'm not going to go through the products as is. The only thing I want to pinpoint here is the workflow composer. So this is, well, actually, let me ask you a question. How many of you guys know the BWC, the Brocade Workflow Composer, or StackStorm? 1, 2. Okay. So this is a pretty interesting, DevOps automation tool set that we actually have now, which would allow you to do a lot of things with that one. I have a couple of slides on that one as well later on. But that's basically the only thing I want to kind of mention here, because that's, the automation, the visibility for the fabrics underneath and what you do with those fabrics. So starting to look at the IP fabric for an IXP. So here's a couple of things for you. So how many of you, or let me actually ask a question that I was asking earlier on, that how many of you guys know SPB? There was a few hands. How many of you know, Trill? There was a few hands. How many of you know IP? I guess I get a handful of, a handful of, sorry, I get a room full of people actually putting up their hands saying that I do know IP. So that's a clear definition of, a fabric would be based on IP, due to the fact that if you look at the internet today, right, it's BGP IP, it's well known. You have a problem in IP, there's a lot of people understanding how to troubleshoot IP. So this is truly, dictating the factor that IP is the way to go for fabrics. And then, there is a couple of other topics here as well that why you would go with IP. But you can read through the slide by yourself. I'm not going to dig into the details on that one. But I think the clear message here is that, IP, BGP is well understood. It has been out there for a while. The internet is based on BGP, right? So that is the right path to take to actually build fabrics. So looking at the protocols from a simplified protocol stack with truly internet reliability on that one, I think I more or less kind of fetched all of these things in my previous statement of why IP, why BGP. So moving to the next one is then the overlay, VXLAN. So BGP, multi-protocol BGP-based EVPN. This is what you see on the slide is more like carrier-centric things. So I'm not going to read through these things. It's more just as an information for you. I think it's kind of key to look at this more from an IXP point of view, because I don't think you guys as such do a lot of multi-tenancy. I might be wrong here, but what you can see here is that there's a lot of layer 2, layer 3 different functions you can do with EVPN as such. Now, if we take a step back again and more, look at this from an IXP point of view than from a data center or through, multi-service platform point of view, I don't think all of these are applicable to you. So, sorry for this is a busy slide. I think to kind of summarize this slide, it tells you truly the story around EVPN. So, if you look at VPLS and PBB, so PBB stands for Provider Backbone Bridging, which is, the Mackie encapsulation. So some of you guys might remember PBT times. provide a backbone transport, which were like, metro technologies. So PBB is, as said, Mac in Mac. That's part of the Fabric Connect SPB-based fabric that Extreme do have to offer today. So having said that, obviously, if you look at VPLS, it has been out there for ages. It's well-proven technology. However, you have some challenges with that one. It can't really do all of the stuff. Hence, you actually start to look into things like the flooding on learning in a VPLS. You still do that, on your data plane. Now, if you look at EVPN, now you start to look at have a true abstraction happening where you would have then a separate control plane and a data plane, which would allow you to truly do, some unique things. Like, for instance, multi-homing into 2 CPEs with active-active. You can't really do that with VPLS today, right? So there is some other functions that, EVPN would allow you to do. And then you can see here just, a listing of more or less, why you would go with EVPN. There's different verticals, there's different, use cases for this one. It is pretty unique. And to kind of, continue building the picture around EVPN, as you can see here, so you have a kind of a common control plane being EVPN for multiple data planes. So you have, VXLAN is just one data plane. You have MPLS and you actually have PBB as well based on the standards. So EVPN is truly spec'd up for multiple data planes, which kind of allows you to think of EVPN as truly the next gen control plane technology. Now, if you start to look at what EVPN is, how many of you guys know what EVPN is all about? So there's a few here. Okay, so in a nutshell, EVPN allows you to basically populate your route table with MAC routes, saying that I would have in my BGP table basic MAC routes, which allow me to, do some clever things with that one. So in principle, EVPN, is just another address family within multi-protocol BGP, where you would have then, as said, where you would populate your route table with MAC routes. So you could basically have just a MAC route, or you could have an MAC and an IP, which is basically an ARP entry. Or as you can see, the gray ones, where you have an Ethernet tag. So it truly allows you to also start to separate things on an Ethernet level. And then on the bottom, you actually see the MPLS part, where you start to see that you can look at labels. So as said, EVPN is truly thought of being the next-gen control plane. And it's also, thought of being truly a standard one, meaning that multi-vendor interoperation would be applicable on that one. So this is truly the way forward on the control plane part. If we now start to look at this from a IXP design point of view, as I was mentioning, EVPN with VXLAN as an overlay, providing your connectivity through the fabric. And my definition of the fabric in an IXP environment is now it's more like the exchange itself, your internet exchange, which needs to provide a layer 2 path. That's fine. However, one of the challenges you have with the approach of VXLAN, as I kind of was mentioning in my intro, is the fact that by default, you use your IP underlay, which basically means that I'm going to do equal cost multipath hashing based on how my VXLAN header is actually formatted. So if I actually want to do some clever things like putting the traffic in the network where I want to have it, I can't really do it with VXLAN overlay. And I guess you guys follow me on that one. That's the challenge. So now if you start to look at VXLAN, you know, initially it was meant to be in the data center. Having said that, many of the IXPs tend to look at having VXLAN within the exchange itself. But that then raises some challenges around, you know, how would I be able to actually put the traffic in a given path in my exchange? I can't really do that. Hence, I'm actually, so this is just a slide of the VXLAN header, how it looks like. You're going to add in some overlay on that one. Sorry, not overlay, some offset on that one due to the encapsulation mechanism. But where I actually want to get is to this one, is that if you look at VXLAN as a layer 2 overlay in an exchange compared to MPLS VPLS as the overlay in your exchange, guess what? VPLS gives you so much more due to the fact that you can do your traffic engineering. And that's truly what it's MPLS is all about. So if you go back, or if you go back to this slide and have a look at this one, obviously MPLS do bring some more complexity into your design, but if you can hide that complexity with automation tools, what it actually brings to the table is the traffic engineering possibilities of truly putting the traffic in the network where you want to have it, which was the unique thing with MPLS when it was founded, many years back. It's truly a carrier, technology in that sense. And, kind of the takeaway on a high level here is that these are the fundamental differences if you go VXLAN or VPLS as the overlay. So going into the programmability, so what you'll have in this picture is basically, some kind of a fabric underneath. Then you have your automation here. So I can see here I have like 4 minutes left, and I think I still have like 10 slides. So there's no way I'm going to go through all of my slides in this period of time. But I just want to kind of, mention a couple of key things around the automation part. I think, this slide itself is pretty self-explanatory. So what it actually tells you is that you have something called the EVC, which stands for Extreme Workflow Composer, which is truly the Stackstone product itself, which is, an automation suite for a DevOps environment, allowing you to do things like different automation tasks. So to give you, try to build a picture in some sense for you. What it gives you is, if you look at it from a fabric point of view, as you can see in the picture here, so assume that you want to, for instance, add a leaf node into this fabric. So the one being on the bottom right. With the workflow composer, you could actually have basically the workflow composer running an automation with a zero-touch provisioning-like thing. Once you add the leaf node, it would automate the adding of that node, and it would actually add it to the fabric itself to be part of the fabric. This is just one thing it could do. Obviously, it's so many other things you can do with it as well. I do want to mention conceptually, something as well from the SLX architecture. It's pretty interesting from an architectural point of view because it brings into the picture a kind of, you have a architecture where you have a system VM and then you have a guest VM, a third-party VM, which means that I'm running my kind of switch OS on a system VM, but then I have a guest VM, a third-party VM, where I could actually run some kind of an application, for instance. And then you would see on your interface modules, you have the same thing. You basically have a VM on that one. Now, why do I want to mention this? This is just kind of a recap of the previous one. Here's a key thing. Based on that architecture now, assume that, or let me actually take an example. In an IXP environment, you struggle with a lot of ARP messages, right? Now say that what if if I'm able to run some kind of an application within my switch architecture that would fetch my ARP packages and ARP sponge, basically snoop on my ARP packages on VPLS, and then do something clever with those ones. Basically, once you hit a threshold, then you would start to, kind of mitigate those ones. With this architecture, it would allow you to basically run such an application within the switch architecture based in a VM. And now if you look at this one, that's kind of key in the sense that you have a dedicated 10 gig analytics path, from your kind of switch itself into this guest VM. And then you have your dedicated control path to your system VM. Why am I mentioning this? Because if you think of this one as you only have a single control path and running a kind of application like that on your system OS, which some vendors might allow you to do, the problem you have is that you're getting into a race condition in your control path, because now you have traffic that you kind of want to analyze, stealing the bandwidth from kind of housekeeping traffic, being, your route updates, all of that stuff, which is not ideal. So, I think this architecture truly gives you one kind of interesting aspect on running an application like, just one example, the ARP sponge on the switch hardware itself. So I see a red screen here already. This is just a high-level view of the stack storm stuff. So truly the workflow composer, as I was mentioning. What I kind of want to mention in a couple of words is obviously the evolution of the network architectures. So we might all remember the old three-tiered architecture. It was not ideal for east-to-west traffic. It was ideal for north-to-south traffic. Then you went into your spine leaf architecture, which obviously is ideal for east-to-west traffic. Now somebody could, raise the question that how do I scale on that one? So what you see is then, phase 3 being kind of going into a hyperscale architecture where you go spine leaf, and then you have a super spine, and this is how you truly scale up, your architecture. Here's a couple of slides going more in details into these ones. So I think I kind of went through this one already, so I think, my message was pretty clear on this one. I want to share with you guys some thoughts around the fabrics, some thoughts around, the overlays, being the as mentioned, EVPN kind of seen as a truly interesting next-gen control plane for the data planes being MPLS, BBB, and VXLAN. So with that one said, I can see the red screen here already, and that basically concludes my presentation. So thank you. Are there any questions? Okay, thank you.
Thank you, Michael.
Thanks. Dando prosseguimento, eu gostaria de agradecer.
Now, continuing, I'd like to thank our sponsors, Facebook, Netflix, APS, Equinix, PX Technologies, Eletronet, Coherent, Semig Telecom, Juniper, Grupo Binário, TEDEC, Extreme, Fullnet, Precision Norticom, Rucus, and especially Google, Abranet, and NTT, our platinum sponsors. And continuing, I'd like to invite Greg Hart from Finisar. He will talk about the latest trends in high-speed optics. Boa tarde.
Thanks to Nick VR for having Finisar here. They've been a great partner, and we're honored and privileged to be here. I know we're running short on time, so I'll try to get us caught up as fast as I can. 2 quick slides on Finisar. We're located in Silicon Valley. We're actually right between Google and Cisco. Finisar has $1.4 billion in annual revenue, so we ship a little more than $100 million worth of transceivers a month every month. We ship a part every 1.5 seconds. Just a quick overview on some of the products and applications we'll be talking about and some of the customers. And I'll primarily focus today mainly on where our parts are used in the data center. Besides these customers, Finisar is in all the hyperscale Web 2.0 data centers around the world, and we sell to multiple carriers as well. So if I just take a look at the first slide on just kind of where the basic architecture is for data centers and where we find optics, we still see a lot of 10 gigabit being deployed inside the data centers. There's a lot of 10 gig intra-rack, and we see 25 gig now really coming on board strongly inside the rack, intra-rack, connecting the different racks together. We see a lot of 10 and 40 gig links and traffic, and we've seen a lot of 100 gig short reach products there as well. And then as we go from buildings to buildings, we see a lot of 10, 40, 100 gig. We now see some 200 gig, and we see some coherent applications, which I'll just briefly touch on in a little bit. 50 gig and 100 gig to the server will quickly follow, and I've got a couple slides to touch on that. Again, between data centers, we still see a lot of 10 and 40 gig being deployed today, but we see a lot more 100 gig now starting to come on board. And for long spans, I'll talk a little bit later, just a little bit about some DWDM and some coherent products and technology. So if you just take a look at your standard generic kind of data center right on the server rack, right, we've got a lot of active optical cable interconnects. We've got a lot of multi-mode fiber there. Traditionally, a lot of 10 gigabit kind of speeds, right? Everything connects up through the server racks to the TOR, the top of rack switch, of course. We'll do interconnects over to the leaf and the spines. There'll be either DACs, usually if it's 3 meters or less, or active optical cables, which is basically an optical version of a DAC, if you will, for distances beyond 3 meters and also for higher speeds. QSFP is basically a 40 gig interconnect, and then as we move closer and closer into the core, there's always a lot of 100 gig there, and CFP2 and CFP4 are 2 of the higher volume shipments that Finisar makes into the core of the data centers. I'll go quickly through the product stuff. You know, the main intent is just to kind of show some of the new things that are coming out. 25 gig optical transceivers are right now starting to ramp up to the kinds of 100,000 a month kind of volumes. So we're seeing this as a industry-wide 25 gig is rapidly taking off. And of course, you can easily break out 100 gig into 4 25 gig ports as well. So there's been a lot of activity and interest over the past 6 months in 25 gig. 100 gig has been in high volume production now. There's Finisar's at the 100,000 pieces a month overall in 100 gig shipments. The industry wide, many companies are shipping 100 gig in very high volumes, especially inside the data centers. We really see the QSFP 28 form factor really with the highest volume shipping. CWDM, which is the 2 kilometer version, and I'll talk a little bit about a CWDM4 Lite version, which Facebook helped pioneer, which is at a 500 meter reach. Again, active optical cables. Why do people use active optical cables inside their data centers? The short version answer is cost. If you're going to buy an active optical cable, or you would buy 2 optical transceivers and the fiber, the active optical cable is usually somewhere around 25% less in price. So if you're going to buy a optical link with 2 transceivers and a fiber, and let's just say to keep the math easy, it was $100 US, you would get that exact same functionality with an active optical cable, and you would pay $75. So we're shipping hundreds of thousands of AOCs, and the industry is as well, into data centers all around the world. There's a lot of different variations at 100 gig. Actually, probably too many variations. If you're a customer, what you want is short lead times and low prices. And so the fewer products there are and the more competitors you have focused on those products, the higher the economies of scale, the shorter the lead times, and the lower the prices are overall in the market. If you have multiple different options and multiple volume on many different platforms, the industry is more fragmented. But at least from the Finisar perspective, for 100 gig, where we see the highest volumes worldwide are CWDM4, QSFP28, especially when I talk data centers. If I'm talking carriers, we still see a lot of CFP2, a lot of CFP4 volume. So just the advice there for any customer, right? Whatever format you're going to choose, whatever 100 gig product you're going to choose, right? It just makes sense. You want to try to go with a broadly supported product, one that's supported by multiple suppliers, so that it gives you options and choices. If you go with a proprietary product over a market standard kind of product, generally there's fewer suppliers to support you. So if we take a look now on 100 gig in the data centers, right? In the beginning, I'll start from the bottom and go up. You know, the TOR to the server was basically all 10 gig SR. SR is short reach multi-mode fiber. And then go into the leaf to the TOR, right? We're looking at 40 gig. Again, multi-mode fiber, short reach. To the spine, to the leaf switch, it was 40 gig. Some of the bigger mega data centers go all single mode. So now I start to see a split between multi-mode and single mode fiber, SR and LR. And then, again, these are the initial rollouts and deployments to the core switch and to the router. It was 40 gig LR as well. Now what we're starting to see on the next layer is from the TOR switch to the server links, we're starting to see a lot of activity now going from 10 gig to 25 gig. To the leaf switch, we're starting to see a lot of deployments now with 100 gig, with short reach, with active optical cables, and I'll also talk about SWDM, which is an industry-wide alliance involving multi-mode fiber and extending its usefulness in the data center. On the spine to the leaf switches, we see a lot more 100 gig CWDM, extended reach, and PSM4 is something that we really see starting to take off more and more and more in 2018. And we see 100 gig a lot now up at the core and to the router and to the spine. And then when we take a look at the next generation, so the green is where we started, the blue is kind of where we're at today, the red is what we see coming down the pipeline in the next year or so. Right, we see 50 gig now going from the TOR switch to the server links. Oops. We see 200 and 400 gig from the leaf switch to the TOR links. We see 200 and 400 gig to the spine switch into the leaf. And again, we see 200 and 400 gig from the core switch to the spine. So this is what we see coming down the pipeline probably in the next 12 to 24 months. There's millions and millions of dollars being invested in 200 and 400 gigabit product development today. Again, I'm trying to keep us and get us back on track. I won't go through all these different formats. Just the purpose of this slide is when you take a look at 100 gig, for example, there's many different options, depending if you want to use single mode fiber, if you want to use multi-mode fiber, if you're, you know, duplex, if you're in the parallel MPO camp, many different options, right? So when we take a look then at large data centers, right, there's a lot of them that want to use, you know, cost-effective single mode QSFP28. And this is what I was talking about at the beginning of the presentation. So Facebook, as I think some of you know, has a has OCP, Open Compute Project. Finisar is a member of Open Compute. The last meeting that we were at was in March in San Jose. Facebook had listed us as one of their suppliers for this. What Facebook then did is came to optical suppliers and said, we want the 100 gig product, but we want it at a lower price point. And I don't need to go 2 kilometers. 95% of my need is 500 meters or less. And our data centers are in temperature ranges that we can well control. So if we can relax temperature specs and we can relax the distance, can the price of the optics go down? And indeed, the answer is yes. And Facebook pioneered this and have bought millions and millions of dollars of CWDM4 Lite type products. And all of this can be found in the public domain under OCP, Open Compute. And this is something that many different companies from around the world participate in an open environment to basically have a plug and play type environment. And you can see the complete specifications there at the link at the bottom of the slide. So when we started looking then at multi-mode fiber, and brownfield is where people already have installations out there, we're running into some customers that basically wanted to continue to use multi-mode fiber because it was already deployed and inside their data center. But they were having technology changes migrating to 40 gig and 100 gig from 10 gig. So I'll show you at the few slides later, there's an industry alliance that formed around this to solve the problem. It's called the Sdm Alliance. And so basically, we've come up with a product that allows you to keep in your duplex LC-based multi-mode fiber infrastructure. And if you use SWDM products, which are available for multiple suppliers, you can now easily migrate your data center from 10 gig to 40 gig to 100 gig using your same multi-mode fiber LC duplex infrastructure. And this is just one example of multiple companies getting together to address a market need. So yeah, that's the punchline is you can now migrate to the higher data rates without swapping out your multi-mode infrastructure. So then on the other side, shortwave WDM uses in the 850 nanometer range. This is, again, people wanting to stick with multi-mode fiber inside their data centers, right? They want to keep using the duplex LC connectors. They didn't want to pull out and go to MPO style fiber, and they didn't want to go to all single mode type infrastructure either. They wanted to use the existing multi-mode fiber infrastructure that they have in place. So this is just a product that, again, was specifically created to allow 40 gig and 100 gig over the existing multi-mode infrastructure inside data centers. For greenfield applications, now this is people who are deploying new fiber and they want to deploy OM3, OM4, OM5, but they want to stick with multi-mode because the transceivers in particular are more cost effective for short reach multi-mode fiber than they are for long reach single mode fiber. So again, SWDM4 has come up with products that can now extend the reach of multi-mode infrastructure inside the data center. So this allows the multi-mode data center to be extended so people don't have to go to a single mode infrastructure just to get the extra reach that they were looking for. And we've seen this trend happen in areas where data centers continue to grow in size, but again, the data center wants to stick with the multi-mode fiber infrastructure. So OM5 multi-mode also really helps future-proof the infrastructure. So we're starting to see some of the newer builds out use it because it'll be able to use 200 and 400 and even 800 gig interfaces in the future. So it's just another one of the trends that we see going forward for construction inside the data centers. And yeah, so if we take a look at then the two different options that you can do, the first one is basically you take your standard SR4, which is your short reach module. You run it through the MPO jumper cable, the MPO module panel. You have your trunk cabling, right? You do it on the other side. The structured 100 gig cabling below it with the SWDM4 basically just allows you to do the same functionality, only over duplex LC-based fiber instead of MPO fiber. And so these are just two different solutions based on what your infrastructure is of your data center today. You can do basically the same functionality with two different products depending on what infrastructure you already have invested in. So this is the Sdm Alliance. There's multiple companies, multiple suppliers around the world that have products and offerings specifically focused on the SDM type applications, which really is basically getting more out of installed base multi-mode fiber, or future-proofing if you're going to use OM5 multi-mode fiber, so you can go to 200, 400, and 800 gig. That's really what the SWDM Alliance is all about. I won't go through all the different product slides. I know they're in the presentation. I know you have access to these. I mean, there's just many different varieties, many different versions. Again, it's just really kind of basically depending on what the reach is that you're looking for, what the data rate is that you're looking for. Again, just another version of all the different varieties that you can see at 100 gig. Some are proprietary, some are IEEE standards based. Finisar sees a lot more proprietary solutions found in specific data centers where providers control and own both links, versus in our carrier side of the business or other parts of the business where we're more focused just on IEEE standards. So I'll just touch briefly on Coherent. We do have some big data center customers who want to connect a data center A to data center B, and they're 80 kilometers, 100 kilometers apart. We work with some of our key customers who you can see their equipment here to supply Coherent type solutions to make it easy for the customers to connect their data centers together. This is just a few examples of some of the people that we work with out in the industry to make this happen. And there's also another Facebook initiative called TIP. And Acton and EdgeCore has recently announced and published an open source design for coherent transmission as well. And again, this is another Facebook initiative, and again, Finisar is part of TIP as well. There's also bi-directional coherent transmission. Again, this is just if fiber exhaustion is a problem and you want to go bi-di. There's bi-di coherent product solutions that are out and available in the marketplace today as well. We always recommend going pluggable, but it really just depends on what your particular situation and your need is. This is just a real quick kind of history lesson, and it takes us out to 2020. So in the year 2010, when 10 gig was really in the mainstream, right, we were running at boxes of 1.28 terabits. Right then, as 25G started to surface, more in the latter part of 2015, the boxes are running 3.2 terabits. Right now, today then, 2017, 2018, as we see 25 gig and 50 gig now emerging, right? We see boxes capable of 6.4 terabits. And then in the year 2020, when 50 gig really we believe will dominate and be running the market, we see boxes at 12.8 terabits. So look how quickly we've gone in 10 years from 1.28 terabits to 12.8 terabits, right? Just keeps going and going and going. So beyond the 3.2 terabits, right, we see a lot of standard works being done on 50, 200, 400 gig. We see the modulation scheme changing from NRZ to PAM4. Optics suppliers around the world are investing millions and millions of dollars in these new technologies, right? A lot of them will use, totally new lasers, silicon photonics, lots of different schemes and tricks inside the magic little box to make it work. So there's a tremendous amount of money around the world by optics firms going into these next generation devices. Again, I won't go through this whole chart. It's an eyesore, but this just shows you a small listing of some of the different next generation 100 gigabit Ethernet standards coming down the pipeline. And there's many of them, many. 400 gig, the same way. This is just a very, very small sampling of what some of the 400 gig IEEE 802.3BS work is around. There's many, many 400 gig standards being proposed. And so if I just break it down, again, this is just kind of taking a look at the future. It's still very early on for 400 gig to really understand and decide which ones are going to win and which ones aren't. But a best guess at this point from Finisar would be if you're looking for 400 gig at 10 kilometers, it'll be based on LR4, single mode fiber. If you're looking still to stay with single mode fiber, but you only need to go 2 kilometers, we believe the FR4 version is going to win. It's less expensive than the LR4. And if you're going to be deploying 400 gig over multi-mode fiber, we think the SWDM 8 product, which can go 100 meters, has a very strong value proposition. There's 2 major camps at 400 gig if you want. Finisar supports both camps. One is a CFP8 based, and there's a third as well. There's an OSFP standard, which Finisar is also participating in. CFP we see going more into the into router type applications, and in QSFP DD, which stands for double density, we really see that going into a lot more data center applications, and also it's backwards compatible with the previous versions of the QSFP 28 product, which is very attractive to many different customers. So trends in high speeds optics, we're seeing the world change right now, going to 25 and 100 gig, moving away from 10 to 40 gig. Now, Finisar still ships millions of 1 gig transceivers a year. So we don't think the 10 and 40 gig business is going to evaporate or go away. We just see more and more 25 and 100 gig being deployed in 2017 than was in 2016. And in 2018, 19, we expect that trend to continue, right? And the multi-source interfaces, really at the end of the day, when the market can find that sweet spot, and again today in data centers, it's primarily at 100 gig, then the CWDM4 interface. I mean, when you have the most suppliers with the most volume competing for the share, that's where you see the price points really get driven down the fastest. And we just predict the same thing happens at 200, 400, 800 gig. Whatever the volume leader is, that's usually where the most competitors focus their production, and that's usually where you see the most rapid decline in pricing. SWDM4, again, if you're a data center trying to extend or continue to use multi-mode fiber, there's an alliance there that can help support that. 100 gig light variants, which aren't IEEE standardized, can save cost and money. Facebook proved that with their CWDM4 light spec that's openly published, and multiple companies supply product to Facebook on that part. Coherent technology, we're really seeing take off. It's one of the faster growing parts within Finisar for connecting data centers up and together. And As I said earlier, there's millions and millions of dollars being invested around the world by multiple firms for 200 and 400 gig data centers. Thank you very much, and I beat the clock. I will be here all day today and tomorrow, and if there's any questions now, I'd be happy to address them. Okay, well, thank you very much for your time this afternoon. It was an honor and privilege to present to you.
Bom, queria dar um aviso. Agora a gente vai fazer uma pausa aí para o coffee break.
Now we will break for coffee. On your way back, we'll have a panel about microducts and cables, followed by a session on the peeling block guys. The peering guys. Anyone that is present and who would like to introduce yourself as content provider, or anyone that would like to leverage your peering, just come upstairs and briefly present yourself, 1 minute max. So in the happy hour session, the beer, peer, and gear, you'll be able to have a more efficient network. Thank you, and see you back in 25 minutes.
a slightly different subject. We will talk about microducts and microcables. We'll have a panel with people from 3 different areas. So I'd like to invite Evelyn Araújo Vieira from Duraline, Brazil. Gustavo Candolo from Prismian Group. José Carlos Nunes from Empretec. And Luiz Felipe Lorenzoni from Level 3. He will be moderating this panel. Good afternoon. I'm Luis Felipe Lorenzoni. I work at CenturyLink, previous level 3. I'm planner. I'm a physician. I work with optical fiber since 1985. It's a pleasure to be here sharing knowledge with you. Well, I apologize. We should have CenturyLink over there, but I haven't received the master slide from CenturyLink. But I'm here as Lorenzoni and as sharing my knowledge to you. I'm not going to talk about level 3 or CenturyLink. What motivated myself and the group here is or was to start to expand our networks, our optical networks, and find it highly occupied with chaotic occupations and presenting our projects for increase the network, I receiving negatives from the utilities. The poles or the posts have no longer space. Of the 30 cables, how many have authorization? I don't know. We lost control. So, due to this invasion of the poles, we it provoked, and considering the high poles occupation and the high cost of conventional underground network, it motivated us to get back to an old idea. This move of micro cables occurred in the beginnings of the 90s in Brazil, but the solution was not adequate and the poles still have room to receive more cables. With this, in future come of 2014, I will direct to this point here. You can see this. This is a high motivation for cables. Many companies do not respect and they invade the poles and they cause a deorganized occupation. And 300 reais per meter is the cost of the underground network. Aerial cable, it's 25 reais. So it's 12 times more expensive, the underground network. And as a private company, we need to present business case. We need to go to aerial. But in the large cities, in the large urban centers, and the center areas of the large centers, aerial occupation is impossible unless you install cable without respecting any permits. So since it's not the case, we are unable to implement the network to do our business. And knowing the existence of a micro cable, I asked the cable manufacturer. I know all of them. I know I have the product, but I cannot sell because it's not authorized by Anatel. This was the justification not to sell it. So we got together. This is the group. I want to start with this. We gathered my knowledge and the knowledge of my colleagues. We gathered all the cable manufacturers in Brazil, all of these one listed here, several operators, some duct manufacturers, Duraline is here, and some constructors that build networks, two associations, Telcomp that aggregates all operators, and e-commerce are associated, and CPQD that gave the technical structure, and all companies, the manufacturers of devices, consultants, and other company that sell optical network material. With this group, we build a forum that we called Microcable Forum, and we elaborate the requisites. And I asked, why the cable is not authorized by Anatel? Because there is no requisites or requirements. What requirements? A set of specifications and test procedures that should be met by all manufacturers so that the product is authorized. So let's write them at 200 hands. I don't want to know your industrial secrecy. Let's create an specification that meet the consumers, all the manufacturers, and we will exclude low quality manufacturers. So let's have a minimum requirement specs that will ensure the presence of all manufacturers, but the correct manufacturers in the Brazilian market. So all of them here are present. They are multinational companies, all of them. They are located all over the planet, and we did this not to let people say that it's to come with a wire saying it's a micro optical micro cable. We went to Anatel, and with this, we have the requirements authorized by Anatel. After this, we worked with the cable manufacturers for have their products authorized. They were concerned because concerned with the microduct quality because nobody wanted a hose from a shower, with all respect, because it has its function, but nobody saying that this would be a micro duct. The micro cable is not micro cable because we remove all the mechanical protections, and these mechanical properties are transferred to the micro product. And with this, we also uh, elaborated an ABNT rule or a standard for microducts. I insist, we are still constructing the best practices. We had people from the government, the Ministry of Communication, Prodan, and Anatel. And we elaborate some specifications for project. This is still in the phase of conclusion. We achieved two goals, the authorization of the micro cable and the specs of the microduct. Now construction will be easier. Well, I will show you very briefly because our colleagues will detail this. But here, the microduct has an area 6 times smaller than the conventional duct. With this, we have a less impacting construction, much more sustainable. And here, another motivation was underground conventional constructions, all the impact, all the trauma caused to the city, to our pocket when we have an conventional underground construction. The noise to the employees, the damages for the existing construction, you have gas, water installations, the traffic. We disrupt the traffic, we cause a traffic jam, we recover the pavement, and we end up causing obstacles to the citizens, uh, even if they are walking, whether they are walking or driving, and we generate waste. And with the construction of the micro cable, with the micro technology, the telecommunications micro network, micro cable alone is not sustainable, not even the micro product. This is a system. You need to have a micro branch to install the micro duct. This is a typical trench where you excavate 3 times less, and with this you generate less waste, less need for recap, the aspects of microduct construction. You just draw a line, and the recovery is almost unseeable. It is thinner than the a tire. There are some cost comparisons. It's totally out of order, these slides. Well, I'm here. We have the micro trench system, cable blowing, micro cable, and micro duct. All these 4 pillars, they need to be present in order to have a proper system of network microtechnology. We have Empretec, which is the most uh, specialized company in cable blowing, and these are experiences in Spain for cutting. We have several experiences in Brazil for TIM, Telefônica. He is the a 2.51 1-inch trench. And here, something important, the cost of the cable. We have a cheaper cost compared to the conventional cable. We can use fiber band load influence 657. The execution of 300 meters of trench drops 5 times. The difficulty is smaller, greater flexibility of the system, and the pavement recovery, it's also smaller. These are some figures we have for cost per kilometer of trench, cost per kilometer of the duct. This number I have already experienced. This is a fact. The cost of cable is still due to the low level of consumption. We didn't have an important impact on price, but we do have an impact. Micro cable cost is slightly less than the conventional cable. And we are reaching parameters of half of the cost per meter of the entire network, and the pavement recovery cost is 20 times less. This is the important work with the government, with the city hall. When we say that we are going to open a trench and we will have a lower recap, the municipalities has a great resistance. Doria said that he didn't want us to recap 30 meters, but 100. If you go to Ribeirão Preto, if you make two cuts, you have to recap the entire block. Now we have to convince the city, the municipalities. Here in São Paulo, the Secretary of Works gave me authorization to create a study group because we have three kinds: rigid, flexible, and sidewalk. You see the repairing structures. You have the specs for construction. The network microtechnology comes to stay. To open a trench of 30, 40, 50 centimeters of wide at 6 centimeters of depth is unfeasible. The technical difficulty is big and the quantity of scaved area and cost is becoming more important. In conventional trench, you open 30 meters per day. With a micro trench, you open 300. Micro trench in roads in small cities, this has a lower impact, and you have to convince the municipalities and the optimum place to install. And this is someone I say to you of going there with the level 3 duct and having no space for you. When you have the gut and you start the asphalt, which is an area, dividing area. This is the perfect place to construct the micro trench. You cut 20 or 30 centimeters and you can install 7, 8 ducts of 18 millimeters, and with this you have all the accessories for bypass termination, uh, to avoid the penetration of water and dirt. You have all the accessories. And just to conclude, to leave time to my friends, the network microtechnology for those who want to invest with uh, less money, it's the must. For those who are internet provider that want to implement your network faster, this is the best alternative. Today, a cable with 288 fibers, it has 10 millimeters, 10.5 millimeters, compared to 18, 19 that we had in the past. So a duct, a micro duct with 12 millimeters, or better, 14 millimeters internal you launch a cable of 288 fibers. And these are cables with groups of 24 fibers. Anatel used only to authorized with 200 bench. Now, with 288, it needed 2 crowns. But if you want to form the SZ, when you accommodate the tubes around the core, when you had this with the 2 crowns to get a pair of fiber in the crown upside down, it was not feasible. And now we can do this with 24 fibers per tube batch. So you have 12 groups, which is easier to work with it. And microdot, the other alternative, you have a heavily occupied buildings with no more room for cables. I don't know here, but it must be very difficult to pass a cable here. So you pass one micro duct and you blow one micro cable. Today, we don't have this basic unity cables that you blow 1 or 2 fibers. This is not authorized, so we cannot use. But it's the next work.
Então é isso, a mensagem é essa.
That's my final message. Micro network technology, micro trench, that is a reality available in the market with products, constructors, and they promote a network guarantee and the service that we deliver to our clients. Thank you. Any questions?
Beleza. Meu. Se alguém quiser fazer contato comigo.
If you want to get in touch with me, my email is luislorenzoni 1959 at yahoo.com.br. I can answer to any questions. It's a great honor to share with you your concerns and help you. Thank you.
You take a deep sigh and you wave a passing goodbye and you set your course.
Alô? Oi. Tem algumas perguntas do Wellison Tomé pelo chat do YouTube.
We have here a question from a follower in the YouTube. What is the max depth of this product installation?
Tem algum tipo de sinalização antes de chegar no microduto? A terceira existe custo mensal com as prefeituras sobre o uso de domínio?
Well, actually, 4 questions, but I mean, he just made the first one. What is the max depth of the microtrench? That will depend on the diameter of the used disk. We recommend 30 centimeters, where you can place 7 ducts and still leave some proper room where the city hall, if they come to do some asphalt or cement, that will not reach the microducts. For rimming, for if the city hall rims it. We can stain the final coverage of the microtrench, showing that there is a optical cable. What is the next question? Is there any monthly cost by the city halls for domain use? He's talking about passage right, yes? The cost for passage right today in the telco, that is a very representative cost. And however, everyone wants to charge for that. Some, they say that the use of underground. The underground use is union right only and not city halls.
Favoráveis a esse entendimento.
Some decisions they favor such an understanding, others do not. Also, there is the law of the wires and things for the non-payment of the passage right, and everybody wants to charge. That's so complicated. There are some law firms specialized in this topic. You may talk to them, consult them throughout Telcomp. So get in touch with Telcomp and check that. Last question. Where do you place
Nessa topologia,
the junction box? Junction boxes, they are conventional because they are a derivation point. Interconnection is the room where the network may grow. What they have now are some junction boxes. There are two things, underground boxes and the wheel that will get the junction box where you will end the two ends, the two final ends of the boxes. There are some manufacturers that they present junction boxes smaller than the conventional ones to accommodate fibers. But we are not so worried about the size of the junction boxes, as we have to accommodate too many fibers to reach several cables. I need to have some room for maneuvers. So I'm not concerned about miniatures of junction boxes, but end of cables where you have the end of the hill and you have to start another one, no need for a backbone. There are some smaller boxes available in the market that can be easily used as well, and they are much smaller than the conventional ones. Hello, Lois. My name is Wellington. I am a provider owner. Can you make a parallel between these programs and some other cables? What's the difference? Microducts or digged cables? Well, I do not recommend digged cables. We started with this sort of cables in the beginning of the 90s, where you dig in the cable, you open the trench, and you dig in. That requires too much maintenance. If there is any breakage, you have to do two joints to prepare two junctions. Sometimes that changes how the dip, the knife, or maybe the arm of the plow that changes or varies, and then you end up installing in surfaces that are irregular, in touch with the soil, and may suffer some actions of ants and other rodents. Underground, you find this kind of animals, the rodents, and there is no way as to pull back cables that locks you up. You cannot perform properly in your network. I do not recommend that. I no longer install it. And microduct, you will open a small hole. You'll be able to hire a smaller plug.
Uma valetinha menor e vai instalar seu duto e vai soprar. Você vai ter rapidez na instalação.
You have a much faster action blowing. According to the norms, you have to blow 2 kilometers in 1 hour if your network is straight. Microduct wins 10 to 0. Do not use directly the cable, as that will lead to relevant maintenance problems. In case there is a tear and the city hall will do some maintenance and then they break all the microducts, do I have to change all of them, the whole line? With the microduct, you can have some junctions, and the repair will be exactly as the one you do with the conventional duct. There are junctions, they have to be transparent. You will link ducts and you'll be able to blow a new cable. The micro cable hasn't got the high or a great traction support. It can support as much as 500 newtons. So be careful when you pull back the technical reserve to allow new junctions.
A vantagem é o seguinte, quando você faz o cabo diretamente
when you underground the cable, you have deeper trenches, and the speed is much faster. With the micro trench, you need a smaller hole with a high velocity, and you can place many more fibers exactly in the same area. This is the main advantage. In the 90s, who installed the cable today cannot remove it and reinstall microducts and microcables. Those that had installed before, they are removing the old cables and they are installing microducts, microcables, and they have the same passage right with a survival rate much longer. Yeah, I'm doing that. Some places I no longer have ducts and I am microducting conventional ducts. I'm taking one duct into three. Non-destructive methodologies for these products. Are there anyone? I will answer yes, and I'll let Evelyn from Duraline to elaborate more on your question. Well, I will start my presentation and then I will answer questions, other questions.
Oi, pessoal. Não, só por causa do horário, acho que era legal fazerem as apresentações primeiro e a gente deixar os questionamentos.
Well, maybe you should start with your presentation and let the questions to the end. Otherwise, we will run late here. I like to start my presentation with this picture, as this is the Brazilian reality for aerial networks. There is no more room to grow in the air network, and our underground ducts, they are totally jammed. Today, 3,000 microducts are being installed in a 40 millimeters duct, which threefold his network capacity.
Eu vou ser pouquinho rápida para os meus colegas.
I'll try to be a bit faster.
Aqui que eu falo pouco, o que veio fazer a microtecnologia?
What about microtechnology? What to expect from that? Providers today are improving their ability thanks to some strategies. Revenue increase, operational cost reduction, and also implementing cost reductions. And what is microtechnology? Microduct is not like a shower hose that Lorenzoni mentioned. It couldn't be like that, of course. Microduct is made of high-density polyethylene with a very much reduced diameter. Today we may install a cable of 96, 72 fibers, I guess that's the smallest one available in the market, with a 6 millimeters diameter. We are comparing that to those 10 millimeters to 12 millimeters traditional cables that before would go through ducts of 32, 40 with the same passage right. I have a very brief video explaining why microtechnology came to Brazil. With private organizations, with the Anatel, the public carrier, public power is available because of micro cable that came to overcome that need. This is a video that was made in Argentina, as we are lagging behind them in microtechnology. But much can be explained, so it will be very clear what microtechnology is. Who is familiarized with the situation? That's very unpleasant. We have a mess. Yeah, we are missing the audio. I'm trying to translate the subtitles, but it's a bit too fast. I apologize. If there is audio, we will translate. If not, I'm sorry.
Bom, Aí eu estou fazendo uma instalação de 7 microdutos.
Here we are deploying 7 microducts within a traditional gallery. I am installing it to increase my capacity within an existing network. How can microtechnology help our infrastructure? Microtrend
também com puxamento, né, com HDD.
I can also do that with pooling, HDD, a non-destructive methodology. I can pool that microduct exactly as the traditional methodology. I work with a very high traction resistance, where I can deploy 300 fibers per microduct when I multiply them by the number of microducts. In a world of fast communication, and to meet such a demand, we need new cables. Who is familiarized to that situation or not? Well, you see a big mess, uncomfortable to our citizens, much traffic, and consequences to our environment. However, there is an alternative with the microtechnology, small cables, fibers with a higher capability to face the system infrastructure. That is very important for the development of cabling, avoiding traffic or any lack of comfortable to our neighbors and communities. Traditional cables, they are protected and they avoid rupture. Thanks to a new application technology, microtechnology cables, they save space as they are smaller, and they are installed by blowing and not frozen, and we can improve installation time. Air plus microfiber, we help installation, we reduce additional impacts. As part of the microduct portfolios, what are those? What is supposed to be a microduct? A duct that is as big as 18 millimeters in diameter that can support cables of 83 fibers. When I talk about 18 millimeters, I'm talking about external outer diameter. A 32 duct can face a cable of 238 fibers. If I have a micro trench and if I place 7 micro ducts, my capacity grows to 2,300 fibers. That's quite a lot if we compare to what we have today. Here are some examples of microducts. I have two types. We have an array here known as future path. That is a model that can be deployed by the non-destructive methodology. And this is another model to be fixed into micro trenches, up to 7 centimeters wide trenches. Duraline duct has an internal coverage known as silicore, where all microcables they have to blow, which helps and reduces the friction coefficient in the cable during installation. Someone has asked about junctions in the microducts. All of them, they are the push-fit system. There is no additional tool to be used to install microducts or to allow junctions at the end of the hill.
Aqui eu mostro os tipos de instalação.
Here I have different types of installations.
Pronta e precisa
who's got a ready gallery and needs to increase its capacity. I can place 3 microducts of 12 millimeters each one of them with 144 fibers. Within 100 millimeters duct, I can install 2 future paths with 7 pathways, each one in addition to the existing cable.
Aqui são exemplos, imagens de instalação.
These are examples of installations in an existing network with microducts. And here is the micro trench, the examples and size. We say to open a trench with 30 centimeters depth. It depends on the machine, and up to 7 centimeters wide, where you can deploy 14 microduct, depending on how you're going to resurfacing the asphalt. This is the buried installation, especially for those who use non-destructive method. This could be pulled with the same strength as a 20 millimeter jigger. You can also use the Qualcomm to use and the duct and the cable. And this is an image on how this fiber is installed. Every microfiber must be installed with the pulling method or blow. This is my presentation. I will now give the floor to Gustavo or Zé.
Eu posso acrescentar alguma coisa para as palavras da Evelyn. Primeiro é o seguinte, só para colocar mais argumentação nas palavras dela.
Just to give more argumentation to her words. The cable is blown and the duct as well. In the morning we will blow. an existing infrastructure where the pre-existing cable was removed, and we will blow 3 microducts, and within it 3 high-capacity cables. This will not triple the installed capacity. This will increase in tenfold with the existing past cost of the trench that was open. Another point, the microduct can also be blown. What's the difference because blowing and pulling? It goes further. It suffers less influence of the pulling effort. So with this, the cables could decrease their mechanical resistance. And this group, everybody participated with technology, increasing the productivity and efficiency. Is the case of the cable development and the microduct, etc. So blowing will go further with less labor, with more clear, with less external interferences, and this work is done with the traffic going on normally. Good afternoon. I will talk about the micro cables. So the optical micro cables. The idea is to compact the more you can the fiber, protecting it. So we try to remove the most of the protection and share the protection with the microduct. A traditional cable here in this table has 14.6 millimeters, and the micro cable 8 millimeters. So we can put 192 fibers. This picture, this is a pen, and this cable has 72 fibers. It's a 5.8 millimeters cable. In a very small space, we have the possibility of having a huge amount of fibers. The idea of microtechnology can be buried, can be a hero. This video shows our solution where you have the duct line, you launch all the ducts, and you have several accessories of easy installation with no tools. After launch, you can direct the duct, and then blowing, you blow the cable. It's always blown. We removed the protection so I can pull with a 50 kilos traction only. So a cable of 144 weighs 70 kilos per kilometer. If I have a traction of 50 kilos, I cannot pull. A small quantity, yes, but the cable was designed to be blown. This is the microtechnology idea. This is Evelyn video. The great advantage is this, the occupation of the micro ducts. Here is a conventional cable of 144. I can launch 3 micro ducts and 3 micro cables. I can multiply by 3 very easily. Everything blown is small machines, small equipment. And how can we reduce the cable? When we have the tube loose in the past, with 2.5 millimeters to install 12 fibers. Today, with 1.15, we have the same protection. So materials improvement allowed us this protection of the cables. In the 90s, the cable with protection, with corrugated steel cap, a nylon cap, several protection, even due to lack of knowledge when we started to produce optical cables. And today we have the same 144 fibers in 7.8 millimeters. And how can we do this? I can work with the glass of the optical fiber, with the acrylate and the projects, the design. We can remove the protection or construct the cable in a different way to put a very compacted fiber. And how can I do this with the glass? You work with the drop cable. This is a GME 57 fiber. It's a bent branch, the drop fiber. If I get a monomode fiber with a curve, I have 11 dB of loss. If I've had the band bright, I can make how many turns I want, and I have a 0.19 dBs. So it's a fiber that was born for internal use for bending 90-degree angles, very favorable. I can confine the light in the core of the fiber, so I can stress the fiber into the cable and reduce its diameter. This is the profile of the fiber. You have the core and the outer area. When I get the Gen 57, I open a trench. This is a this trench in the glass and the core. And with this, I can confine the light within the core, and I can have very small bendings without losing any power. So I can manufacture the cable with GME 52 or 57 and install more fibers in the same space. The other possibility is the improvement of the acrylate. We developed an acrylate with a possibility of protecting the glass against micro cracks, much superior than 20 years ago. This shows the micro bending, micro cracks that can propagate to the cask and go to the curvature. This is a black line with all these losses, especially in the windows above 150, where we have a Sigicon, where this will very sensitive. When I have my improved acrylate with the glass of the GME 57, it comes here. No losses against microbanding, whether it's the cable, the life shelf of this cable, and for any transmission window is preserved. So with this type of fiber, you can work with the same cable. So it is a future-proof cable for any color or a transmission. And since I have a better glass and a better acrylate, I can reduce the diameter of the fiber, not the glass. I can go from 240 to 200 micron. So I have the same glass, 125 micron, in terms of junction or splice is the same, but I reduce the amount of acrylate from 245 to 200, where I used to pass 2 cables today, I can pass 3 cables. Now I can put 292 fibers. And I can also use different materials. I can have a loose cable with a central element and the tubes up to 24 fibers inside, or work with a technology called micromodals, where I have the fibers and a very thin protection. I can stretch it. You fit with your hands. You don't have the central element. It's a very flexible cable, easy to install. I put all the protections, and the central element is put on the cape, on the cap, and I have a longitudinal fiber where I can open the cap and have access. These are the three possibilities to reduce the cable diameter.
Brasil, o microcabo não é uma...
Well, micro technology is not new. It's 15 years ago. Argentina uses this already for 5 years at least. So 7-1 on us. So we are starting in Brazil to use this technology. And without doing the math, comparing a buried and a micro cable network, 30% reduction. This is the certified cable by Anatel. We have 6 millimeters up to 72 fibers, 144. I can work from 8.5 to 12 diameters, or 8.1 with 24 fibers per tube. This 10 per 12. It's a very small microduct deploying a large amount of fibers and identify with the color code. And some examples in Brazil. This was in Rio. This is a constructor, and this is a duct, conventional duct and cable. And in the presentations, this was a 4 kilometers shared by all these operators here. Some pictures, the size of the trench, and here the foot of a person, and these were the conclusions. But the important is they installed conventional subducts. The operator with more ducts had 2 ducts of 2 per 40. If micro cables were used 40 by 10, we would deploy 50 products and 1,078 fibers with a total of 1,600 fibers. Maybe a shallow trench with 50 microducts. Evelyn would be happy of selling it, but a faster and shallow trench and cheaper one. And this is a São Paulo example. This was in Barueri. This is a cable blowing in Barueri 2 months ago. This is the compressor, is small equipment. And now people were accommodating the micro cable. This is the blowing machine. It is fast. You installed 50, 60 meters per minute. You see the speed here. 450 meters have been already installed. This was a 730 meters track. We installed this in 30 minutes. We blowed 15 minutes. This is really fast. This is the great advantage. Small equipment, less labor is required, and you reduce the cost when you compare one network to the other. Thank you very much, and I will be happy to answer any questions you have.
Eu só queria concluir o seguinte, a nossa apresentação.
I'd like to add something. I'm almost 60.
O usuário de telecom.
And I always learned they have the right.
Falar. Vou ficar sem dó.
Well, in vote, the client can say whatever they want, whenever they want, to whomever they want. This is the right of our client. And I've seen that the more band we offer, more band the user requires. We all know that. And the services, we are reaching the channel limit. So fiber optics, well, you did the math in Henkel function, and I'm from the 19th century, but you know that the possible passing band in a fiber is about 2 terabyte bits. And today we are reaching this limit. Today we are more and more requiring or demanding fiber optics. The 20-year-old people, I work for them. If a guy of 20 years old or someone older, but any young guy, who wants to say no, there is a transmission media that is more effective than fiber optics. Well, I will applaud. In my opinion, there is no other media to transmit band than the fiber optics. And the need for every client is a trend. We are not, well, we have some services that is broadcast, only one pair is enough, like cable TV, but today we have on-demand services, so dedication of a pair of fiber for each user is coming. Well, it has already arrived. We have operators with a pair of fiber for every customer. So microtechnology, I don't gain anything here. I'm just a technician, a technical guy. So the microtechnology came in a moment that is almost irreversible. If you allow me, we have 3 major vendors, very important vendors of microduct, microcable, and blowing installation service. Zé Carlos, he also manufactures the machine, microduct, and microcable. But there are more in the market. You can have your competition with other vendors. We have the specifications that all meet and all them can provide. And also in a sustainable moment. I did an installation of 100 meters in 3 hours. I confess, I really disturbed a lady. She came from her house at 1 a.m. in her Nightingale, and she said, "Are you going to stay for long?" No, no, we are just finishing, and it's only today. If I was doing this with the conventional method, I would disturb her today, tomorrow, and then, and the day after.
Então, a microtecnologia é uma rede.
Microtechnology is a sustainable construction, proper and of lower cost. And it works as a real alternative to the aerial network. That's it. Thank you. Are there any questions?
Agradeço a...
Tem uma pergunta lá atrás.
Tudo bem? Boa tarde a todos aí.
Congratulations to all of you. My name is Marcos from AGC. Last week, a client asked me about the fusion, which does not change much the type of fibers? No, everything the same fibers as the traditional cables, or a fiber from the drop cable that you can make a junction, no problem, or whatsoever. That's it. Thank you. Junction machines, they are prepared for all sorts of references that he's saying, several numbers, 65, 68. I have a lay question from a request perspective. Request proposals for projects, authorizations, and so on. The use of this technology speeds up the project. Is it simpler to reach, or it has to fulfill the same level of bureaucracy? Yes, unfortunately not. That's not totally regulated at some cities, but that does not improve anything at all. It should, but no, it does not. If you have some home installations up to 100 meters in São Paulo, you can have, within 72 hours, you can get an approval and you may start constructing. There are some criteria to be fulfilled, such as length and so on. When you have a buried network, the city hall believes that you are going to destroy the asphalt and so on. So on. You make a trench without blocking so much, and you can install the sub-products. And today that is quite complicated, I think, because mayors and city halls, they do not understand that very well. Bureaucracy in Argentina is less, and micro-interventions are good for the city hall.
São Paulo, de fazer esse trabalho é justamente para mudar isso. Para que não entre no bolo.
And we have to change that in São Paulo as well. Okay, thank you. Thank you to all of you. This Congress is over. Big round of applause to our panelists. And I see you tomorrow.
Bom, gostaria de agradecer os nossos patrocinadores.
I'd like to thank our sponsors, Facebook, Netflix, PX Technology, Electronet, Senig Telecom, Juniper, Binario, TEDEC, Extreme, Phonet,
Rucos e os nossos patrocinadores
and our platinum sponsors, Google, Abranet, and TT.
A gente não tem uma lista de inscrição, nada, então, assim, as pessoas que queiram se apresentar aqui para falar qual o nome da empresa, qual AS.
Well, I guess the translation is over now, because it's just some announcements, and that's it for now. Thank you.
Na apresentação aí que queira fazer, vamos entregar para o pessoal lá atrás da parte de áudio, que acho que a gente consegue rapidamente fazer isso. Pode vir aqui, que aí todo mundo, que a ideia é todo mundo se conhecer aqui e depois, na hora da cerveja, poder fazer um peering melhor.
Olá, eu sou a Ayub, nós somos o Sistema Autônomo.
Autonomous System, PX Technology. We conduct mitigation of DOS attack, IP transit. As to traffic of our CDN, we participate of ATM whenever that is possible. There is no need to request peering with us. Thank you. Anyone else? Don't think so.
Você de onde? Ah, tá ok.
Olá, boa tarde. Estou aguardando a apresentação. Opa, certinho, obrigado. Pessoal, meu nome é Guilherme Alencar, eu sou da
I am from Clouds of Flare. I'm in San Francisco, California based. Would like to promote some peering in Rio de Janeiro. Find here my contacts. Or any other region in Brazil with any other details, just get in touch with this email information. Today, we have 120 data centers in the world, and we perform CDN, DDoS mitigation, and several other services, and some websites, they are using us. Today, 10%, we are responsible for 10% of global traffic. I am at your disposal.
Preferencialmente ATM, mas assim, a gente, para ser direto,
Any offer, send us an email. Yeah, send us an email so we can assess that. Cannot tell you this right now, okay?
Mais alguém quer se apresentar? Ou todo mundo já quer tomar uma cerveja?
Well, I think it's high time everybody goes for a beer, right? No one else wants to present, recess. That's it, people. Enjoy, and you are all invited to participate at the Beer, Gear, and Peer. Enjoy your drinks, and I see you tomorrow. And thanks to all our sponsors. Goodbye.
Coherent, Semig Telecom, a Juniper, Grupo Binário.
He's just listing the sponsors, Platinum, Gold.
O Google, Abranet e NTT. Bom, se não tiver aberto aqui ainda a sala aqui ao lado, é só aguardar uns 10 minutinhos aí que já vai começar, tá?